morning, dear students. Am I audible? Good morning.
Audible, sir. Good morning, sir.
So welcome to design and analysis of algorithms. So we have made a few discussions in space and trade-off, in particularly in order to enhance the input. Okay. So, but we have we have to complete some of the concepts related to dynamic programming, particularly the knapsack problem. Okay. Because the knapsack problem, what we have implemented, we have to discuss the algorithm, the analysis, and as well as the memory functions. Okay. So those things we will continue now. Okay. So before that, I will give the algorithm for this knapsack problem, and we will make some analysis on that. Once we complete that, we shall go for the memory functions. Okay? Shall we continue?
Yes, sir.
Okay. So you take the algorithm for the knapsack problem. Okay. Algorithm. Knapsack. NMW. P. N means number of objects. M means the capacity of the knapsack. W means weights. P means profits, and P is nothing but the value, the final optimal value we are specifying out. So for I is equals to 0 to N2. ಬರ್ಕೊಳ್ಳಿ algorithm ಅನ್ನು ಕಾಪಿ ಮಾಡ್ಕೊಳ್ಳಿ. For J is equals to 0 to F2. If I is equals to 0 or J is equals to 0, B of I comma J means profit. Okay. B of I comma J is equals to 0. Else if W of I greater than J, okay, W of I greater than J, then B of I comma J is equals to B of, if you remember the formula, B of I minus 1 comma J, okay, else means this is first case, this is second case, the last one is the third case. What is the third case? B of I comma J is equals to, can anybody tell me the last final case? Maximum of B of I minus 1 comma J, B of I minus 1 comma J minus W of I plus B of I. End if end for and end for, and this completes the algorithm for the knapsack. So have you taken this?
Copied, sir.
Okay. Now, can you identify the basic operation of this algorithm? What is the basic operation of this algorithm? Whether this statement will be executed maximum number of times, or this statement, or this statement. Which one? Whether this is case 1, this is case 2, and this is case 3. Which is the case
Case
executed
3.
maximum number of times? Since already you have solved this
Case 3.
case 3, very good. So this will be declared as a basic operation. Okay. Now it has been embedded inside two for loops. You can see. So this is for loop 1, that is summation starts from I is equals to 0 to n, and there is another for loop over here. Okay, so that is summation j is equals to 0 to n. So for all this repetition, how many times this basic operation is executed?
One time.
One time it will be executed. Okay, so now we have to find out the analysis part. So if you take this f of m comma n, that is analysis, is equals to sigma I is equals to 0 to n, sigma j is equals to 0 to n 1. Okay, then you apply the formula. So sigma is equals to 0 to n. So m, capital, I mean upper bound is m, lower bound is 0. Okay, plus 1. So it becomes m minus 1. To take m minus 1 outside, sigma is equals to 0 to n. If there is nothing, it is 1.
M, sir.
So I have taken minus 1 outside. Okay, I have taken it outside. So now it becomes m minus 1 into n minus, okay, m minus 1 into m minus. Lydia. So I think this is m minus 0. M minus 0 means m plus 1. This is m plus 1.
N plus 1, N plus 1.
This is m plus 1 into n plus 1. So we can take this as mn. The highest polynomial becomes mn because m into n mn. This is m, this is n, and once again 1. So the highest polynomial product, highest product is mn. So we can declare that f of m comma n is approximately equals to theta of mn. So this will be taken as the time complexity, the analysis part of Knapsack problem. Correct. Over.
Over, sir.
Okay. Okay. I'm going to write this.
Yes, sir.
So next, knapsack problem using memory functions. Let's see there. Knapsack problem using memory. So, what is this memory functions and what is the significance of all those things? Definition part. Then we could take now. Okay. So, what is going to happen in the knapsack problem? Already I have explained. We have a bag, a container, and it has a fixed capacity. Okay. So, we call the fixed capacity as M, capital M, and we have n number of objects, and every object has a weight and as well as the profits. Okay. So, whenever we are going to insert a new item into the knapsack, the capacity of the knapsack is going to be decreased or it is going to be reduced. Okay. So, we can call this as a remaining capacity. So this remaining capacity, when it reaches 0, we have to stop the process of insertion. So under this the knapsack problem, there are two approaches are present. One is a top-down approach, and another one is a bottom-up approach. And what is going to happen in this knapsack problem? We have to use the overlapping subproblems. Means the values what we have calculated in the previous iteration will be used for the current iterations. That is what we can call the subproblems. Okay. So, but what is going to happen here means, so here we are going to find out the values of the values in particularly of the profit, which is not at all required. Some situations we are going to calculate the values which is not at all required. Optimal value is the only one which is what we are going to have. So apart from that, the other values in some scenarios it is not mandatory to calculate. So what is going to happen if you want to find out the values of the unnecessary subproblems? It is going to consume a lot of time complexity. So avoid the number of unnecessary computations and find out only necessary computations. That is the advantages of memory functions. Okay. So how this is different from the traditional knapsack problem? So when you solve the problem, you are going to find out that. Okay. So before that, I am going to give some definition for this memory functions, particularly knapsack problem. I think shall I dictate? Dictate, dear students.
Yes, sir, dictate.
Okay, but for you. Let us compare top-down approach and bottom-up approach. Let us compare top-down approach and bottom-up approach. First point. In top-down approach means we are going from top to the bottom. Okay. So in top-down approach, the algorithm solves common subproblems. The algorithm solves common subproblems more than once. Have you noticed it? Same value what we have obtained will be repeatedly we are going to solve. That is the drawback what we can say. Okay. The algorithm solves common subproblem more than once, and hence it is inefficient, Okay, so this problem, that is the problems what we have already solved, we are going to repeatedly solve. Okay, so this is inefficiency. This can be overcome. So this can be avoided by using the another approach that is called as a bottom-up approach. Number 2, second point. That is a bottom-up approach. In dynamic programming, in dynamic programming, which uses bottom-up approach, the common subproblems are solved. The common subproblems are solved only once. Only once. Full stop. But the solution to some of the subproblems, is often not necessary. To get the solution. For their problem, for the given problem. Okay, next paragraph. The goal of memory functions is to solve only subproblems that are necessary. And doing it only once. So next to in memory functions ಬಗ್ಗೆ ಸ್ವಲ್ಪ ಡೀಟೇಲ್ಸ್ ತಗೊಳ್ಳೋಣ. Next paragraph ಕೊಡಿ. Memory functions. First point. This method uses top-down approach to solve the problem and maintains a table to store the computed results as done by bottom-up approach. Number 2, second point. Initially, the entries are filled with hyphen. The entries are filled with hyphen, and the minus symbol. Hyphen indicating they have not been computed. Number 3. When a new value has to be computed, this method checks the corresponding entry in the table. Full stop. If this entry is not hyphen, The value is retrieved from the table. The value is retrieved from the table. Full stop. Otherwise, it is computed. Otherwise, it is computed recursively. Otherwise, it is computed recursively and stored in the corresponding location of the table. Corresponding location of the table. Okay. Next paragraph, right? The inputs to the algorithm, before the algorithm is called, are. So in inputs ಬರುತ್ತೆ memory functions ಅಲ್ಲಿ ನೋಡೋಣ. First one is n. So what is n? N means what?
Number of objects.
N means number of objects. Second one, capital M, small m. So small m means capacity of the knapsack. Next, W. What is W?
Weight.
So W means weights. Okay. Purple is an array of weights. Next purple is P. What is P?
Profit.
Purple array of profits. Next, purple V. Is a two-dimensional array. V is a two-dimensional array of size n plus 1 rows and m plus 1 columns. So next I will give the algorithm. So a clear explanation of memory functions we are going to understand only when I am going to solve the problem, because if I keep on telling you the theoretical concepts, it is a bit difficult to understand. So that is why. So I am going to take the algorithm now. So after the algorithm, once you solve the problem using memory functions, you can notice the difference, you can understand it in a better way. So Bakpari algorithm. The top icon. F is the memory function. Okay. Next. P of I comma k less than 0. ಈ ಫಾರ್ಮುಲಾಸ್ ಅನ್ನು ಡಿಫಾಲ್ಟ್ ಆಗಿ ಇಟ್ಕೊಂಡ್ಬಿಡಿ ಅದು ಬಂದೇ ಬರುತ್ತೆ. If W of I greater than J, then the value or profit equals to F of I minus 1 comma J, else value is equals to F of I minus J, F of I comma J minus W of I plus P of I then B of I comma J is equals to value. So this value will be as I and we will be. But for
Yes, sir.
okay. Yes, students, it may have a problem with that. A problem is a bit there is a problem. So that is why I will take the problem in my next class. Okay. So I'm going to stop here. If you have any queries, you can ask me. Color of this.
ಹಾಂ ಸರ್ ರಬ್ ಮಾಡಿ.
So give your attendance in the chat box. So in my next class, very important class, I am going to solve the knapsack problem using memory functions. Okay. So till then, have a nice day. Okay. And submit all of your assignment. I have noticed it that only 3 students they have submitted. Okay. So keep on checking the Google Classrooms. So once you complete your assignment, submit as early as possible. Okay. With all this, I'm going to stop here. Okay, if you have any queries, you can ask me. With the clarity of the concept, you are going to get only after solving the problem. So in the next class, I'm going to solve it. Okay. So also, I'm going to take extra classes whenever it is possible. Okay. So I'm going to give the information on that. Okay. With all this, I'm going to stop here. Thank you so much for joining Design and Analysis of Calculus.